Hello and welcome to the Web Express presentation of Advanced Drills, Skip Pockets, and 3D PDF, a closer look. As part of the Closer Look series, I hope to give you some insight into these new features in Mastercam 2021. So let's get started. It's a Mastercam part file. This part file is it's a part from a front end assembly on a Formula One car. You can see I've got a stock model here. If I activate my stock model, you can see this part has been pretty much machined. The only thing that remains to do are drill these holes in. They've all been spot drilled. And if we take a look at my part, there's a couple areas here and a couple holes that I want to zero in on. One is this area here. And if we look at it, I've got material and then an air gap and a material. Previous to 2021, a couple ways I could attack this. I could drill it from this side and drill through this material, and then create a new plane and come in from the other way and drill through this material. Or I could do what I'm going to show you right now, and that's we're going to drill through here with a drill tool path. I'm going to go, first thing I need to do is go into my planes, and I have a plane created, so I can use this as my tool plane. So there's my tool plane for that face. Now I'm going to go in and create a drill tool path. I have the ability to select a solid face. I don't have to select the solid edge anymore, or I don't have to create a piece of wireframe to select that arc to drill a hole. I can select that solid face. The green arrow on my part designates the direction in which my drill is going to come. In this case, it's going to come from top down, obviously the way I wanted it. But if for whatever reason I wanted to come the other way, I can simply click on that arrow, and now my drill is going to kind of come in the other way. I'm going to revert that back. I'll go ahead and hit the green check mark. I'm going to grab my 1/4 inch drill. It's already got a holder associated with it. I'm going to go into my cut parameters, and we're going to peck this, and I'm going to use a peck of 50 thousandths of an inch. My linking parameters, because I now selected that solid cylinder, I have a couple extra boxes on this page. One is calculate incremental values from holes and lines. I want to activate that. And the last that I need to check is to calculate depth from the top of hole and line. I want to activate that. I'm going to use a 1 inch clearance. I'm going to retract 100 thousandths. My top of stock is an incremental 0. And I'm not sure what my depth is. I'm going to use my depth tab here and select the bottom of my geometry. It gives me a depth. And then I'm going to activate tip comp just so I go through. I'm going to break through by 10 thousandths. Make sure my plane is set up, which it should be. We'll go ahead and calculate that tool path. And here's what I get. Pretty much what you would expect. The problem with this tool path is once I break through this material, it continues to peck. And this is all air. This is wasted time and wasted motion. Let's take a look at the new toolpath in Mastercam 2021 that corrects this issue. I'm going to go into the parameters for this toolpath. I'm going to go to toolpath type, and you can see now there's an advanced drill. I'm using the same tool. I'm using the same geometry, so I don't have to modify that. Let's go into linking parameters. And the first thing I want to point out in the linking parameters page is there's no longer a depth. With the new advanced drill toolpath, depth is controlled in the cut parameters page, not the linking parameters. I'm going to change some values here. I'm going to change this to 1 inch incremental, and I'm going to only use that at the start and end. And I'm going to use a retract of 10 thousandths incremental. And let's go into the cut parameters page. Cut parameters page is brand new. You can see right now I just have one cylinder defined, and there's some more information down here at the bottom. We'll talk about that shortly. Let's take a look at my geometry first of all. So I'm going to hide this dialog. And if we look at our geometry, it's basically 3 sections. I've got material, air, and then material. I'm not sure what these are. I know what my overall depth is, but I don't know what the material depth is or my air depth is. So I'm going to go and check that. If I had a print or if I knew the part, was more familiar with the part, I would know what those values are, but I don't. So I'm going to say analyze distance. And we're going to go from here to here, and it gives me 1/4 of an inch as my first material step. My second material step, same thing, 1/4 inch. And then my air is 659. And those numbers either need to be noted or remembered because we're going to use them. So I'm going to hit escape. Okay. And as I said, we've got 3 sections that we need to deal with. Well, right now I only have 1 defined. On the bottom of this dialog, you can see I have a plus sign and a big red X. The plus sign does exactly what you think. It's going to add sections for me to deal with. This particular case, I've got 3. So my first depth is going to be that first material, which is minus 1/4 of an inch. The feed rate in which I want to drill this material, I'm just going to put 5 inches a minute. We use an RPM of 1,000. And I'm going to turn my coolant onto flood. I do want to use a tip comp, so I'm going to go ahead and select that. I'm not going to extend the depth. I just want to extend this so my drill completely breaks through that stock. We use chip break. The one thing about these 4 boxes that I want to explain briefly is we're typically used to working from the top down in Mastercam. Because minimum pec needs to be set before I can set my first pec and nominal pec, especially if they're going to be smaller than this value, I need to change it first. So I'm going to go ahead and change that to 10 thousandths. And while I'm down here, I'm going to change my retract to 10 thousandths. My pec, I'm going to change to 30. And my first pec, I'm going to change to 30 as well. I could put a comment in here if I wanted to. First segment, material segment 1. Whatever I wanted to do that would remind either myself or my operator what this does. Put that in. And let's go to the segment number 2. Segment number 2 is my air. And if you recall, that was 659 deep. So 659 plus 250 is a minus 909. However, the feed rate, because it is air, I'm going to go much faster. I'm going to go 200 inches a minute. RPM, I don't really need to change. I could change that if I wanted to. I could make it faster, slower. I could make it 0 if I wanted to do that, but I'm going to leave it at 1,000. And the same thing with my coolant. I could turn the coolant off at this point, but in this particular scenario, the amount of air that I'm machining is so small, there's really no reason to turn the coolant on and off. So I'm just going to leave that option selected. I am, however, not going to do anything down here. I'm not going to set any type of segment or tip comp. I'm going to go right to my depth. So now we'll talk about segment 3. And segment 3 is going to be minus 1.159. Again, the 0.909 plus 250. And you can see as I do this over to the right, my graphics are changing. And that cylinder is now not just 1 cylinder, it's 3. And all 3 of those cylinders are related to these numbers. And if I put my mouse over those, it will automatically change the highlighted area. So I'm not done with this yet. I still need to come in here now and say tip comp. How about if I change these as well? We're going to go back to 5 inches a minute, 1,000 RPMs, and I need to make sure that my flood is on. Now I can come down and select tip comp. And we're going to use chip break once again. I'm going to change that value to 10 thousandths. Change this value to 10 thousandths. And again, we're going to pec at 30. Once I have these set, as you see over here to the right, as I highlight them, they change. And the last highlighted will be the last highlighted up here. Comments, put all that information in. The rest of this information should have remembered from the toolpath. None of that's going to change. So I'm going to go ahead and hit the green check mark. Recalculate that toolpath. And let's backplot it again. I'm going to expand this so we can see the details. Expand this brief just a little bit so we can see it. There we go. And I'm going to play it. And you'll see the feed rate. I expanded it enough, which it doesn't look like I did. There we go. We'll change to 200. And back to 5. Much more efficient. And I didn't show it before, but that other toolpath took roughly 30 seconds. And with all the pecs removed in the center section, the air, we've reduced it to just under 12 seconds. It's quite an improvement. Where this is going to come in really handy is a couple areas. If we look at this part over here, we have no choice in this area but to do what we just did. We're going to drill it from this side through. Previous versions, we had no choice. We could program a toolpath from here to here, do another toolpath that essentially is air from here to here, and then a third toolpath from here to here. Well, that's not very efficient. Now with the new advanced drill, we can do that all in one shot. Let's take a look at another way that we would use this. I'm going to open up another part file. This is a part file of a very simple mold base. There we go. So you can see I've got a pocket in my mold base. I've got some water lines here, and these water lines go to a certain depth. And then I have a crossover water line here as well. I'm going to go into my levels. Into my planes. I've got a plane here that I'm going to use as a section view. Gives us a better look at the water lines and the crossovers that I'm talking about. So if these water lines were put in first, and then this water line was put in, if you've ever done or run into this situation, you know that this area right here can be problematic. We have to be careful when it breaks through because it wants to chip the end of the drill. And then we want to be careful when it breaks through on this side. With the new toolpath and the new ability to control these sections independently, I can come in here. And in my cut parameters, I've defined all of those depths and the feed rates accordingly. So I'm going to go down to a depth of 1.8 at 5 inches a minute. And then from 1.8 to 2.2, we're going to go 2 inches a minute, so on and so forth. I change the spindle speeds. If I want to go slower, go faster. And if we take a look at the result, we get something that looks like this. If you've ever dealt with this situation, you know how difficult these holes can be. And truth be told, if I was actually going to cut this, I would put this hole in first and then do the long holes going the other way. And then I only have to deal with 2 breakthroughs. But one toolpath now handles that bad situation. I'm going to turn my my section view off so we can now look at these holes. What this is these are clearance holes. There's 2 inserts that go into this pocket. And the clearance holes are clearance holes for water lines. The inserts need to be cooled. So there's an in and an out. The way that you would put this hole in previous versions, would you put this hole in through the stock and then stop, put this hole in, again, stop, turn the part around so it would require another setup and come in from this way. So another setup, another pickup. Well, with the new advanced drill, I can come in from one side. I get a longer drill, and I'm going to chip break this, and then I'm going to feed at 200-300 inches a minute, and I'm going to go in from that side. And if I go ahead and expand this and look at the information here, just under 3 minutes. This is an 8-inch wide mold base. So just under 3 minutes. Here is the same toolpath, only not advanced. And if I go in and take a look at the amount of time it took for this, 7 minutes. If you look at the rapid moves in this toolpath, it's just short of the total time the advanced drill toolpath took. So it's definitely going to save you some time. So that's one of the things, the new features that we're going to talk about. The second new feature we're going to talk about is a new feature in Optirough. Skip all pockets. Open up a third part file here. go. Hide my stock here for just a second. And if we take a look at same part file, right? But now I want to rough this with Optirough. So I'm just going to go ahead and program using my my stock using Optirough. Go Optirough. I'm going to change my stock to leave values to 15 for both the wall and the floor. Triple click on my solid so it selects the entire solid. We'll say end selection. For my toolpath control, I do want to use a boundary chain, so I'm going to go into my levels. How about I activate that first? Now we'll go into my levels. We'll activate the stock and we'll select that face. I want to use the outside of that as my boundary. Green check mark that. I'm going to use a 3/4 inch diameter Ishkar. We're going to take a couple seconds to talk about the radial chip thinning function. So I'm going to skip ahead, go into my cut parameters, and we're going to change this to 50. I'm going to go back into my tool. And I will set some parameters here so the numbers make a little bit more sense. So I set a surface feet of 650 and a feet per tooth of 4 thousandths. Notice when I select the radial chip thinning function button, nothing happened. The reason nothing happened is because this is based on a 50% step over. Because my step over is 50%, these numbers don't change. If I click on this, however, notice my feed rate and spindle speed get grayed out because I have the ability to change these two settings, but not these, because the radial chip thinning function at a 50% step over with this surface feet and this feet per tooth needs to go this fast. This is going to create a chip of optimal thickness, and it's going to remove the heat from my job. What does that do? Well, my heat's not going to go in the cutter, and my heat's not going to go in my part. It's going to go in the chip, and that's what I want. Well, if I go into my cut parameters and change this, let's just say I change it to 25%, and I go back into my tool, my feed rate is increased. The reason for that is because if I keep my feed rate the same, my step over is smaller, the chip is thinner. Where's the heat going to go? It can't get evacuated in the chip anymore. There's only two other places it can go, either my cutter or my part, neither one of which is optimum. So I increase the feed rate, which is in turn going to increase the chip thickness and give that heat someplace to go. And again, the smaller this value, the larger that value. Just a brief discussion on that. So I'm going to go back into my cut parameters now. We're going to set my cut parameters. I'm going to leave that at 25. Let's step down at 200%. You know what? We'll step down at 133%. We'll step up at 0.1%. Everything else is okay on this page. For my transitions, I'm going to make my entry helix just smaller than the radius of my cutter. My Z clearance, I'm going to start at 50 thousandths. We are going to say come from the outside. Right now, I'm going to turn skip pockets off. I am using the boundary chain. For my steep shallow, I do want to detect limits. And I want to come in here and use my Z coordinate of a point. My minimum Z is going to be the top of my stock. My depth is going to be the top of my vice jaw so I don't run into them. And at 735, I'm going to give that a little extra clearance. I'm going to go 0.875. Everything else should be okay. Let that rip. And there we go. I'm going to use my advanced display to turn everything off except my cutting motion and my entry motion. Those are the two things I want to take a look at. And the cutting motion looks fine, except for these three areas. And the bigger pockets, I'd probably get away with, but I don't think I'm going to get away with this. And if I did, there's a fairly good chance my cutter is going to be damaged. So I want to avoid those areas. How do I avoid those areas? Got a couple ways. Let's go into the parameters for the toolpath. The toolpath control, I could say skip pockets. smaller than, we'll say 2 inches. We'll go ahead and recalculate our toolpath. What that does is it looks at my geometry, and any pocket that's smaller than 2 inches, the cutter won't go into. It's definitely a good way to do this. But you can see it's still entering in the center pocket. And it's still entering over here. The entry helix is the one time in the Optirough toolpath that the end of the cutter is going to get stressed. I want to eliminate as much of that stress in this particular toolpath as I can. So how do I go about doing that? Again, this was one way. Another way is in my levels, I've created some plug surfaces. So I've essentially covered the pockets. So I'm going to go back into my toolpaths, select parameters, go into my model geometry, and add those 2 covers to my geometry. I can come back in here now and uncheck this, or I can leave it checked. It doesn't matter. And recalculate. And when it recalculates, you can see it avoided those pockets. Cut right over, which is not a bad result. We'll go ahead and create a stock model real quick. One thing I want to point out in 2021, when you open up stock model, look where under next to where it says name, there's now a number there. I don't have to remember to go in and put a name in there. It's going to automatically number those for me. We'll use Toolpath 4 as my source. Should take a second or two. And that's my result. I'm going to copy this toolpath down. So I'm going to make sure I select that. I'm going to copy it after. And I'm going to show you the new feature in 2021, Optirough, which is skip all pockets. So instead of me giving it a value, it's going to skip all pockets. I'm going to go into my geometry. I'm going to deselect my covers here. Say end selection. Calculate that toolpath, and while that's calculating, I'll go in and turn my plug surfaces off. And at first glance, it doesn't look much different. It's still acting up here the same as it did. But in this area right here, there's some stock I can remove without using an entry helix because I can come at it from the outside. And that's easier to see if I create another stock model. Again, I'm going to use my stock setup. Now, if I toggle between the 2 stock models, you can see that additional stock that gets removed. The end of the cutter is still in pristine condition because I'm not using it. I'm using the side of the cutter. That's going to be a handy function. One of the things about the Optirough toolpath is it always wants to go in these pockets first. It always seems to want to do that. Now I can avoid those areas. And I still need to machine them, obviously, but I can come back either with another toolpath or I can attack that with another cutter to finish roughing this part. Okay. One other feature I want to show you before I wrap things up is the 3D PDF export, which is new in Mastercam 2021. So you can see I got a toolpath selected. I've got some information about this hole. But if I want to show this to my boss who doesn't have Mastercam, if I want to show it to a customer who doesn't have Mastercam, the only way for me to be able to show him these would be to take pictures or for them to install Mastercam. And that's not really practical or possible to do sometimes. So what I want to do is to make sure the toolpath in question that I want to see is highlighted. I'm going to go into my levels and make sure that my rev change is highlighted. And I want to make sure that my fixture is highlighted because those are the 2 things I want to show. And then I'm going to go File, Save As. And in my types of files I can save, I can now save this as a 3D PDF file. And I already have it. I'm just going to say save and then overwrite it. I'm going to shut down Mastercam. I am now going to open the PDF file. Say trust this document. This PDF file, in order for it to work, has to be opened in the free Adobe Acrobat Reader that you can get online. Now there are other other softwares that you can open PDF files, but in order for this function to work currently, it has to be opened in the Adobe Acrobat Reader, which anybody can go download. It is free. But you'll see it looks almost just like the Mastercam part file. I can rotate it. I got my part, my toolpath, my information about this hole, my fixture. I have the ability over here to the left to turn my levels on and off. So I can turn the fixture off if I don't want to see it. I can turn all my geometry off and just look at the toolpath. I just have the one toolpath highlighted, but if there were more, I could turn those on, turn those off. I can also manipulate my geometry around to all the Mastercam used planes. This is a function that if you use PDFs and you're getting and receiving PDFs, it's probably something that you're definitely going to use. You could send it to your program or your machine operator. If you don't have Mastercam out on the floor, you could send this so he can open this up and get an idea. Oh, that's the fixture that you wanted me to use, not the other one. Get that information and avoid collisions. That's going to bring us to the end of this video. Thank you for your time and enjoy the rest of your day.